Hi students, good morning. Last class we have learned about instrument transformers. What is the instrument transformer? How it can be helped in our power system to measure and detect the abnormal fault conditions at any time. In that we have seen that overall configuration of CTs and PTs, what is the internal diagram and how it operates. Now once again learn in details of current transformer, potential transformer, difference between these two and its application in electrical field. As we know that these instruments used in our substations, high voltage substations, to measure the current in each phase with the help of CTs, and the potential difference between lines or phase, Y phase, B phase, we can use PT. And CT, PT both combined, these instruments can be used for protection of our system from abnormal conditions. Now we know that instrument transformers are classified into two main types. One is current transformer and potential transformer. The current transformer used to measure the current in a high rating devices, and potential transformer used to measure the voltage in HT system. What is the basic concept? Simple transformer principle, induction principles. The CT and PT can be used in case of AC system only. So, because these are the transformers. Transformers input always AC supply only. And in last class we have seen basic configuration how the CT and PT presented. Now you can see at a glance how this one connected. For example, there is a one line is going R phase, Y phase. I want to know that what is the current in the line. So current, and I want to know that what is the voltage in between these two lines. For example, 132 kV voltage line. I cannot use direct my ammeter to measure the current in the line. I cannot use my normal voltmeter to measure the voltage between the two lines because the very high induction effect. And I can use some devices help to measure high range values to know its values. So that is known as an instrument transformer. Okay, instrument transformer. So to measure the instrument transformer which is used to measure the current, that is known as a CT. The instrument transformer which is used to measure the voltage, we can say that is the PT, that is the potential transformer. Now how we are going to connect this thing? So these two lines, if you see, this is a one line, and I want to know this is another line. So I want to measure here. I am going to connect one CT here, and here I connected the ammeter to measure this current. What is the CT ratio? So last class we have seen CT ratio is equal to, for example, this current is going at 100 amperes. Then CT ratio, this will current flows only 5 amperes. What is the CT ratio? 100 is to 1, or we can write the 5 amperes. Okay, actually the CT ratio indicated 100 is to 5 is to 5. That means this is a primary current, these two are the secondary currents. That means what has happened? The primary, this is one, we connected the two secondaries coils. So that means what has happened? So this is connected to the metering purpose, that is ammeter. This connected to protection purpose. So we connected this to the relay. So primary is 1, secondary is this here the S1, S2. So we can sometimes 100 is to 5 is to 5. That means the current which is flowing, and this is equal to primary current, that is 100 amperes, and here 5 amperes will flows when the current in the primary is 100 amperes. Similarly, this is also 5 amperes current flows simultaneously when primary is full load. Okay, so when 500 amperes flows, that is 100 amperes flows, corresponding current induced and will flows here. So already we have seen that. What is a CT? CT has the primary is the number of turns is a 1, and it has the current of I1. The secondary, this is a secondary. So secondary terms are N2 and current is the I2. That is called MMF. Magnetomotive force of primary is equal to the MMF magnetic force of secondary. That is here flux produced by primary MMF and flux produced by secondary MMF always they equal and opposite each other. And in practically this MMF is a different, that difference of MMF will shows the reading of this one. Okay, so this is a CT. Now coming to the PT. Now we connect to the PT between these two terminals. So one terminal is connected here and it is connected to the here. So then it is connected to the our voltmeter. Okay, so voltmeter terminals were there. So this is a primary, this is a secondary. Correspondingly, what is voltage step down here. The current transformer, the current is here, step up here. Okay, this is a PT and this is a CT. So both we can say current transformers. This already we have seen last class. Now let us see the current transformers in details. What is CT? The current transformer is used to measure the current of another circuit. So here one circuit current is the other circuit, and I am going to measure the by ammeter with our CT. Okay, now CTs are used worldwide to monitor the high voltage lines across the national power grids. A CT is designed to produce an alternating current in its secondary winding that is proportional to the current that is measuring in its primary. A current transformer also consists of two windings, namely primary and secondary. Current transformers is basically a step-up transformer. It works on the principle of primary MMF, that is called N1 I1, and secondary MMF N2 I2. Just we have seen. It works on the same principles. Okay, so it works on the same principle as that of the ordinary power transformer, where power transformer will step up the voltage, step down the voltage from primary circuit to the secondary circuit, where generally these power transformers used for the step up purpose at generating stations and at load receiving stations nearby our district headquarters. We can use the power transformers as a step down transformers. And the low range ammeter 0 to 5 amperes is connected in the secondary side of the current transformer. The ammeter is calibrated to read the high current, or it will be provided with a multiplying factor. Last class we have seen. Okay, now so you can see the some current transformers used in our electrical field. If you are observing, so what is that one? So here this is the one, just it is the primary, and here they will provide the secondary, a connected here only. This is the secondary. Okay, so electrically now you can see that, so it is placed in a oil tank. Okay, oil tank for the cooling purpose, continuous oil. And here these terminals, it is placed in a porcelain insulators and separate one box type protection, and from this one the terminals is taken out. Okay, so here terminal, this is called P1, this is called P2. Just is a primary, this is secondary. This insulation, you can see this is insulation, this is a primary, and you can see the terminal coming and going, and this is insulation material, this is a structures. Okay, so same thing, it is a drawing, and so we can use the, this is the primary, this is the secondary. Step up purpose, the current is induced such that the primary, the current, that's I1, and the secondary current, this is the I2. Always CT ratio I1 is to I2 ratio. Correspondingly, induced flows in the secondary, where it is connected to our instruments, regular ammeter. Okay, so you can see another one example of practical current transformer used in 33 kV line. Okay, now you can see this is a one. Same the porcelain insulators, this is a structure, and you can observe the nameplate details. It will shows the all values. Now nowadays we are going to use the optical current transformer. This is the latest one. So based on the optical sensors, it measures the what is the current flowing in the primary. So you can see the figure also. Okay, these are the physical structures of CTs generally used in our electrical field in substations, high voltage stations. In low voltage, we are going to use the extension of ammeter by using the shunts. Okay, the standard material generally used manganese materials are used, and to extend the low range ammeters to the high range ammeters in low voltage. But in case of the high voltages, so we are going to use the to extend the range of our, to measure the higher values with help of the available low ammeter. So we can use this current transformer. Okay, so how can we use these CTs in our regular to measure the current? So what is the internal diagram? So this is a transformer, how the transformer will contain. What is the core, what is the primary, what is the secondary. Whether it is the rectangular, it is maybe circular. It may be solenoid, it may be toroid. What is a toroid? There is no core in toroid. There is a core, that's a solenoid. How it is connected physically, these connections we will see. Okay, now let us see. This is a simple one diagram where it has the iron core. So primary is connected to the supply to load. Then the current which is flowing through this one flows through this winding and induces a flux in the core. And correspondingly, you can see the number of turns N1, the number of turns is the N2. So based on this number of turns, it induces a voltage, and correspondingly when circuit is closed, the current is passing through this ammeter which is connected at these two terminals. Based on the CT ratio, so CT ratio, the current is flowing in the secondary corresponding to the primary current. So that is given to our ammeter. Ammeter is calibrated as per our requirement. Okay, so simple. This is the primary. So it is going to just in the direction. Correspondingly, a magnetic link with the primary and secondary. Correspondingly, it is connected to this one. Okay, the S is the safety switch. Whenever you require to remove the ammeter, then you have to short the secondary. What is the reason? We will see later. Okay, this is the one example, and you can see with help of the toroid also. So this is one example. So this conductor through which the current is flowing, I want to know what is the amps flowing through this conductor. So I can use the one toroid core, and the toroid core is correspondingly is whatever the due to the AC supply in the conductor, and the magnetic flux links with this toroid coil, and coil has a number of turns and correspondingly induces the current that is given to our ammeter. The ammeter will shows how much current is flowing in these windings. Okay, so this is a measurement purpose we are using the CTs. This is the electrical connection of CTs. Previously we have seen the physical construction, now electrical connectivity between the primary and the secondary as well as our metering instruments. Okay, so not only this one, you can see the physical different shapes and different sizes and different terminals of CTs generally used in our electrical small voltage purposes, in domestic purposes. Okay, voltage is LT. The effect of number of turns in the primary winding. So you can see here one loop, only single conductor is a one loop here. So only single conductor, that is the P1 and P2 is two terminals, and the primary winding is a single loop, and the CT ratio is the 120 by 5 amperes or 120 by 5 amperes. That means if 120 amperes flows in primary, then secondary induces only 5 amperes single turns. Now you can see the two turns, so it is the two turns P1 and P2. In this case, what will happen? It's the same range 120 by 5 amperes. At the same time, we can the 60 by 5 amperes also we can use it. And 3 loops, with number of loops increases, what flux linkages increases, N1 increases. Then what is the value of S1, S2? Here the current is a 120 amperes or 5 amperes, same CT ratio, but it can be used the 40 by 5 amps range. Okay, so these are the different types of available CTs in market to measure the current for different applications. Okay. Now, what are the precautions of current transformers? So while using the CTs, one should be remember it is a very dangerous. While you are using CTs at anywhere, so that secondary terminal should be shorted always. Otherwise, what will happen? We'll see. Okay. The secondary of CT should be always shorted. And second one is never open the secondary of CT while its primary winding is energized. So what will happen? The primary energized, primary MMF is present and secondary MMF is become to the zero. Then what are the saturation of core will takes place, and a high dangerous voltage developed across the two terminals. Hence, never open secondary terminals once primary current flows. The CT is always used with its primary winding and connected in series with the line carrying current to be measured. So, where we are going to measure, that is connected as a primary, and secondary is connected to our instruments. So, let us see in this in power system. Okay. So, in power